All right, today we're going to talk about classifying linear systems. So we looked yesterday at how to graph system of equations to find the solutions. So now let's take a look at classifying the different types of systems that are possible when you graph them. And our essential question is, how many solutions will that linear system have, or will any linear system have? So first of all, when we classify systems, a linear system can be either consistent or inconsistent. The difference is that a consistent system will have at least one solution. Notice it says at least one solution. That implies that there could be more than one. An inconsistent system, however, will have no solutions. Then, if your system is consistent, so if there's at least one solution, we can classify it further and say then that it can either be dependent or independent. So a consistent system is dependent if it has an infinite number of solutions. And if it's independent, there will be exactly one solution. Okay, so if we look at what are the different types of solutions that are possible here, we have no solutions if it's an inconsistent system. We have an infinite number of solutions if it's consistent and dependent. And then we have exactly one solution if it's consistent and independent. I realize this can be really confusing because there's a lot of big words and new words without any visuals to go with it. However, I have a diagram for you, a tree map, which kind of shows you a more organized way of looking at this. So all linear systems are either going to be consistent or inconsistent. If they're consistent, meaning they have at least one solution, they are either independent or dependent. So an independent system has exactly one solution. A dependent system would have infinitely many solutions. And if it's inconsistent, we know there are no solutions, or none. So let's look at this another way, in more of a table format. And we'll include the pictures of the graphs this time. So what we have here is the three different scenarios that could exist when you graph a system of linear equations. Think about it. You have two lines. Those two lines will either intersect. They will be the exact same line. I know it's hard to see here, but the red line is actually overlapping the blue line, basically the same line twice. Or you have two lines that will never meet, as in parallel lines. So if you have two lines that intersect at any point, so if they intersect like that at one point, we know that it's consistent because there's at least one solution. If we have two lines that overlap, think about the solutions are the points where they intersect, the points that they have in common. There's at least one solution there as well, so it's consistent. However, if you have two lines that are parallel, will those lines ever touch? No. Because those two lines will never touch, they will never have any points in common, making it an inconsistent system because there are no solutions. Now for the consistent systems, we can classify it further as independent or dependent. Remember, independent means that there's exactly one solution, and that's what we see here. These two lines cross or meet in exactly one point. A dependent system is a system that has an infinite number of solutions, or infinitely many solutions, and that's when your two lines will overlap, essentially creating the same line. So here's our first example, and I'd like you to answer the question in Edpuzzle when it appears. I've gone ahead and graphed the equation using Desmos. So I believe the top equation is the red one, the bottom equation is the blue one. So what I'd like you to do is classify this system using the choices that pop up in Edpuzzle. Now I'd like you to determine the number of solutions. Again, please make your selection in Edpuzzle. All right, here's our second problem. Again, I've taken the two equations. I've gone ahead and graphed using Desmos. The top equation is the red equation. The bottom equation is the blue equation on the graph. So I would like you to, using the picture of the graph here and your notes, classify this linear system. Now I'd like you to go ahead and determine the number of solutions. Make your selection in Edpuzzle. Finally, we have our third example. Here's our system of equations, and here's our graph. You notice that we have a bluish line underneath and the red line right on the same spot. Overlapping lines. So please classify this system by making the correct selection in Edpuzzle. And finally, you may determine the number of solutions. Make your selection in Edpuzzle.